So we're going to have a whole video on passive transport and then a whole nother video on active transport. They're both super important, but I think it's important to kind of separate them out. So the idea of transport is you need the ability to move things across that plasma membrane. And as you can see, we're going to be focusing on passive transport. No added energy required. And substances move from high to low concentration, what we would call down the concentration gradient. Let me just show you what I mean by that. When everybody is kind of familiar with this concept, if you put a little dye pellet or say a little packet of Kool-Aid into a beaker of water, the structure of the dye, the molecules that comprise the dye, will permeate evenly throughout the solution, in this case, probably water. So as it dissolves, as it goes from a solid into a liquid and becomes sort of a part of the solution that surrounds it, part of the solvent, I guess, the solute and the solvent become one, you can see clearly from the color that it spreads evenly. This is the perfect example of going from a highly concentrated structure to an area where it is less concentrated. I know that this sounds really simple, but it's actually super important that you understand the concept of diffusion. High to low, 3 words. You must embed. It's actually very important for everything moving forward in the course and also maybe in your future careers. You must understand high to low, going from an area of high concentration to low concentration. And you're thinking, oh, of course I understand that. That makes sense. I know what it looks like when I put a packet of Kool-Aid into water. But it gets a little bit more complicated when you're trying to move something across that membrane. All of a sudden, the concepts get a little bit more skewed, and it gets a little bit trickier to understand. So what we're looking at in this picture is simple diffusion, where we have the ability for a lipid-soluble solute to simply move across the lipid bilayer. Remember that nonpolar things are attracted to nonpolar things. And so it's easy they can just push past those little phosphate heads there, and they can simply move on through. They come into contact with those fatty acid tails. The fatty acid tail says, go ahead. Now this stuff is more concentrated on this side, so it simply passes through the bilipid membrane and enters the cell. Got it? Makes sense? High concentration, moving to an area of low concentration. The same as we looked at here, but this time it's simply entering the cell. And it would move more quickly if there was really, really high concentration out here and very, very low concentration inside. The ability for that stuff to move across the membrane would increase. Its ability to move, and the speed with which it moved would be faster. Now, what if you were talking about something that was lipid insoluble, something that was, rather than hydrophobic, was hydrophilic? This is something that loves water, such as our carbohydrates, a sugar, or an amino acid, for example. In that case, what we would need is we would require facilitated diffusion. Facilitated diffusion is the idea. Let me look at my definition here. Facilitated diffusion. Sugars, amino acids, or ions are moved through the plasma membrane by binding to protein carriers in the membrane or by moving through channels. Now, by now you should probably recognize that this is some kind of a protein. This particular protein has the shape that allows for this structure to move across the channel. Or in this one, you can actually see that it's changing its shape configuration, where it's open to the outside and then later it's open to the inside, and somehow that's just simply happening. This is the one that we're going to be talking about a little bit more when we have a channel. So a channel is open, and maybe it's simply open to, like, from one side to the other, this sort of like a straw maybe, or a tunnel. Here we have some kind of a solute, such as, I don't know, maybe an ion that is deprived inside of the cell. There's very little of this ion inside of the cell. There's a great deal of this ion outside of the cell. Let's say it's the sodium ion, for example. And this is true. The sodium ion exists in higher concentration outside of the cell in the extracellular fluid and in low concentration in the intracellular fluid. And so if there was a channel that was specifically, now this is the tricky part too, it's usually pretty specific to one thing. If there was a channel that was specifically open to sodium passing through, then the sodium would simply pass down its concentration gradient from an area where it's highly concentrated to an area where it's less concentrated. High to low. So that is facilitated diffusion.